All right, so this is a little bittersweet here. It's probably the last video I am doing for our classes, and we are reviewing chapters 12 to 14, which should be pretty current. Hopefully you remember most of it. So the first thing we're going to talk about is inverse variation. So that's when the product of two values remains constant. And you can look at that as equations like xy equals k, or you can solve for y equals k over x. When you have graphs of inverse variation, your graphs will be in two quadrants of the coordinate plane. This first graph here is when k is going to be positive. So k is positive. I'm just going to put a plus sign. So that will be in quadrant numbers 1 and 3. If k is negative, then your graph is going to be in quadrants 2 and 4. So with inverse variation, the one thing most of you are forgetting to do is to write that equation. So you're always going to write that xy equals k and say what the constant is. So let's do this example here. Graph an inverse variation, y varies inversely is x, y is 2 and x is 3. So I'm going to say, all right, xy equals k. So 2 times 3 equals 6. So the equation I'm graphing is xy equals 6. That is my inverse variation equation for this situation. So some points that work, obviously we know 2 and 3. Just going to write 2 times 3. Also, negative 2 times negative 3. You can have 6 and 1. You can have negative 6, negative 1. So go ahead and plot those points. I like graphing 4 in each of the quadrants and then make your curve. So hopefully your graphs look just like mine after you plotted them. Smooth curves the best you can. Problem 2, y varies inversely. Y is 8 when x is 6. So again, I'm going to figure out what k is. So x times y, 6 times 8 equals 48. So what's our equation? This is the part people forget. We want to write x times y equals 48. That is the inverse variation equation for this problem. So let's find out what y, if x is 4. So 4 y equals 48. I'm going to get y is 12 if x is 4. So that's my second answer. So that's inverse variation. Next is section 2, where we have rational expressions. We learn to simplify them, and excluded values. Excluded values is just where the denominator is equal to 0. You must find your excluded values before you simplify. So I'm going to go ahead and factor the denominator. I want to find my excluded values first. So I know it's going to be a 2x and an x, and the signs are both going to be minus because this is plus, meaning the signs are the same, and this minus 15 means that they're both going to be negative. So let's try a 7 here and a 4 here. 7 plus 8 is 15, so that's good. Now, what's our excluded values? I need to do that right now. So I'll say, 2x minus 7 equals 0, and x minus 4 equals 0. So my excluded values would be 7 over 2 and positive 4. So those are my excluded values. Now I need to simplify it. I'm going to factor the numerator. So the numerator is 2x and x. Signs are different. I'm going to guess that there's a minus 7 here because that's in the denominator. That's a little trick. Use what you have already done. Make this a plus 3, so negative 7 plus 6 is negative x. So that does factor correctly. And then we have 2x minus 7 and then x minus 4. What will reduce? Those 2x minus 7. So what is left? Our final answer, simplified, is x plus 3, x minus 4. And again, our excluded values are right here. Now we're going to multiply rational expressions, and that means some factoring is involved. So I'm going to go ahead and factor my numerator and denominator. So that's pretty crooked. We'll deal with that. So the numerator, we don't have a greatest common factor, so I know it's going to be a 5x and an x. And then factors of 36, I'm going to try 6 and 6 because we have a negative 36 in our middle spot there. So signs are both the same, so that's perfect. We got 36 for the middle, 36 for b, and 5x squared for our a term. All right, so let's do the denominator. I know, again, it's a 5x and an x. And then factors of 30, I'm going to try 5 and 6. I'm going to try the 6 here, though, because that's what we have in the numerator. Let's see if that works. So we'd get a 6 and 25. Signs are different. We do want them to subtract. So I know it's going to be a positive 25 and a minus 6. So that's the factoring of the first rational expression. All right, the second one, I notice I can factor out GCF of 2 for the denominator. All right, everything's factored. Let's simplify before we multiply. So this 2 will cancel. 5x minus 6. Nothing else will simplify here. So our answer is x minus 6 over x plus 5 times x minus 9. And you do not need to multiply those together. You can leave that in factored form just like that. Now, 5 is the dimensional analysis, which is actually an important skill. So we're going to convert 150 feet per second to miles an hour. So I'm going to start with 150 feet over 1 second. I'm going to change my feet first into miles. So I want my feet label to be in the denominator so that the feet cancel out. So miles will be in the numerator. And I know that 1 mile is 5,280 feet. If you don't know that, you could look that up. So now, use some red here, my feet are canceled out and I have miles per second. I want to change that to miles per hour. So I'm going to say, all right, I know seconds has to be in my numerator because I want them to cancel out. And I'm going to go to minutes. There are 60 seconds in 1 minute. So now my seconds cancel out and I have miles per minute. I want to still change that to hours. So I want minutes to go in my numerator. That way those can cancel out and hours to go in my denominator. And again, there are 60 minutes in 1 hour. So I'll cancel out those labels of minutes, and now I have miles per hour. I don't expect you to do this in your head, but you're now going to multiply 150 times 60 times 60. And you're going to get 540,000. You could simplify first if you wanted to, but since we're using a calculator, we can just go ahead and put that there. And the denominator, it's just 5,280 times 1. And this is miles over hour. And then if we do that division in the calculator, we're going to get 102.27 miles per hour. I'm just going to write MPH here. So that's our dimensional analysis. You're going to use that a lot in science classes as well. All right, 6 dividing, just like multiplication, we're going to factor, but when I factor the second rational expression, I'm going to actually change it to a multiplication problem. So I'll factor out the GCF here of the first numerator, and the denominator, I'm going to have an x plus 2 and an x plus 9. All right, and then I'll change it to times. And now, again, I'll take the reciprocal. So x plus 1 will be in the denominator, and the numerator. Factors of 6 that add up to 5 is x plus 2 times x plus 3. If they subtracted, that's when I would have used my 6 and 1. All right, let's see what we can simplify. X plus 2, and that looks like that's it. So what do we get? We get 2, x minus 2, x plus 3, all over x plus 9, x plus 1. All right, again, you don't need to multiply that, leave it as is. All right, now we're going to do synthetic and long division, and I'm starting with synthetic here, and I just set it up quickly for us. So we need to set that divisor, 3x minus 2 equal to 0, to get what we're going to put outside the box. So we have 2/3 here. Then we need to notice the coefficients are 9. We don't have an x squared term, so we put a 0 in there. And then positive 2, negative 10. And I'm going to add a little box here for our remainder. We're going to bring down the 9. Then we multiply 9 times 2/3, and we get 6. 0 plus 6 is 6. Then we multiply 6 times 2/3, and we get 4. 2 plus 4 is 6. Then we multiply 6 times 2/3 again, and we get 4. Negative 10 plus 4 is negative 6. Since we divided by 3, that was our coefficient of our divisor, we need to now divide the 9, 6, and 6 by 3. And we're also going to write our final answer. Again, the degree is going to be 1 less than the original degree. So 9 divided by 3 is 3. And it was x to the third, so now it's x squared. And then don't forget, 6 divided by 3 is 2. It will be x. 6 divided by 3 again is 2. This is our constant. And then it's going to be minus 6 over, what was our divisor? 3x minus 2. So that's synthetic division. Now long division, we're going to set that up here. So 3x minus 2. And then again, you have to make sure you put a 0x squared in. So we have 9x to the third plus 0x squared plus 2x minus 10. And we're going to think, how many times does 3x go into 9x to the third? It goes in 3x squared times. So now we're going to multiply that by 3x and negative 2. We get 9x to the third minus 6x squared. Then you take the opposite of both terms. So minus, and this becomes a plus. And we go ahead and add that. We get 6x squared. Bring down the 2x. How many times does 3x go into 6x squared? 2x times. Multiply. Then take the opposite. And we get 6x. Bring down that minus 10. How many times does 3x go into 6x? It's going to be positive 2. Take the opposite. And we get negative 6. So that would be our remainder, minus 6 over 3x minus 2. And thankfully, it's the same answer because it's the same problem. All right, so last one on this page, adding and subtracting like denominators. So what we're going to do, again, this is adding, so it's a little bit easier than subtracting. We don't have to distribute that negative. What is 5x plus x? 6x. And what is a negative 6y plus 6y? 0. So we have 6x over 24x to the third. We can simplify that. 6 over 24 is 1/4, and x over x to the third is x squared. So we get 1 over 4x squared. All right, so that's it for the second page. We'll have another video explaining the rest.